Pantheon is an iconic Roman building. In fact, it's one of the most famous in the world. Many scholars think it's the most extraordinary building ever built.
The Pantheon in Rome has been around for almost 2,000 years. Its huge concrete dome, which does not have extra support, is an amazing feat of engineering. This large building, along with the aqueducts and ports throughout the ancient Mediterranean, impresses today's engineers. Many Roman concrete buildings last a long time, while modern ones have fallen apart in just a few decades. What did the Romans understand that today's engineers do not? Why does their concrete last so long? Today, we uncover how Roman concrete lasted for centuries and what it can teach us today. So, listen further to discover why engineers worldwide are still amazed by their techniques. Roman engineering flourished from the 1st century BCE to the 1st century CE during the rapid growth of the empire. Many roads, aqueducts, baths and temples were built. The main constituent of this infrastructure was Roman concrete, opus caementicium, made from volcanic ash, lime, water and other materials. The Roman architect Vitruvius describes his construction techniques. Pliny the Elder writes about the material, especially volcanic ash from Pozzuoli near Naples, known as pozzolana. This mixture allowed the Romans to build structures that could face weather conditions and even damage from seawater. These materials offered much more than strength. They were essential for the empire to build many types of structures that could last over time. Roman concrete differs from modern concrete because of its special mixture and how it changes over time. Modern concrete, which uses Portland cement, generally becomes extremely strong in a few years but breaks quickly, particularly when exposed to water. Roman concrete, conversely, gets stronger over hundreds of years. The strongness of Roman concrete is based on a pozzolanic reaction, formed by the reaction of volcanic ash with lime. When they react with water, these elements create calcium aluminum silicate hydrate, CaSH, which holds the materials together in a strong structure. The concrete continues to react with seawater around the ocean and forms new minerals, including aluminum terbermarite and phyllipsite, that fill up very small cracks. The structure heals over time. This process continues further in time and largely contributes to the material's durability, permitting Roman seawalls and piers to endure for millennia against the corrosive action of seawater. This pozzolanic reaction can also explain why Roman concrete is so strong. However, MIT, Harvard, and Italian lab researchers found another prime factor of hot mixing. This technique uses quick lime calcium oxide to mix with volcanic ash before water is added. This results in a highly exothermic reaction, generating temperatures above 200 degrees Celsius. The result is not a smooth liquid mix, but something with small white pieces, called lime clasts. Initially, the clasts were regarded as proof of inadequate mixing, but they were more than that. These inclusions are a healing mechanism. When fracture damage develops in the concrete due to seismic activity or environmental stress, water spreads into these fractures and dissolves the lime clast. The dissolved lime recrystallizes as calcium carbonate, then fills the fractures and heals them. Researchers were able to observe controlled experiments and complete healing of cracks within a few weeks of healing in hot mixing and lime clasts in concrete. This suggests that the Romans may have deliberately formulated their concrete for self-healing, or that this repair feature was not available in modern mixes. The most famous surviving example of Roman concrete is the Pantheon, completed in 128 CE. The widest part of the dome measures 43 meters, making it the biggest unreinforced concrete dome in the world. What makes it even more fantastic is how cleverly the Romans used different materials in different parts of the dome. Heavily materialized basalt was used at the bottom and a lighter pumice was used near the top, reducing the weight and keeping it stable. The Pantheon is strong not merely because the Romans were clever, but also because of their concrete. The lime pieces in the mix might help the dome stay strong by fixing small cracks over time, making the building even stronger. Such an extensive network of aqueducts, as well as big temples, were constructed with Roman concrete. One of the known aqueducts, Aqua Claudia, exceeds 50 miles in length, and its water has supplied Rome for centuries. Aqueducts like the Pont de Gard in France survive to this day, and parts of a few are still operational. The reason for their long survival were the robust and self-healing properties of the concrete used in constructing these aqueducts. The Romans could move water over long distances, which changed city life, and concrete was very important for making this possible. In comparison, today's concrete buildings like roads and bridges often need regular repairs and care. Some of the most impressive examples of Roman concrete strength are in their structures by the sea. Harbours, such as Caesarea Maritima in today's Israel, were made with hydraulic concrete, which can harden underwater. This new idea was groundbreaking. By using pozzolana and lime in moulds underwater, Roman engineers could build harbours and breakwaters that stood up to the damaging effects of seawater. While modern Portland cement breaks down quickly, Roman hydraulic concrete stays strong in these conditions. This is partly because tubermarite and other minerals keep forming, which helps strengthen the concrete over time. Even though it was special, people forgot how to make Roman concrete once the Western Roman Empire fell in 476 CE. Building techniques and methods changed during the Middle Ages, with fewer people using concrete, and so on. The detailed knowledge of how to make this strong material disappeared. Concrete returned in the 19th century with the discovery of Portland cement, but by then, the techniques and materials used to make Roman concrete so strong had been lost. Today, researchers and engineers are trying to learn about Roman concrete again, hoping to use some of its features in their modern buildings. MIT's study of hot mixing and self-healing limeclasts could create new kinds of concrete that last longer and require less care. Concrete production emits 8% of the world's greenhouse gases. A longer-term material could greatly lessen the need for repairs and rebuilding, helping to create a more sustainable infrastructure. Roman concrete is among the strongest materials that humans have ever produced. Its formation was not merely about trial and error. Rather, it was a deliberate and scientific process that helped the Romans establish an empire with structures that are still standing today. Modern engineers look back at the material for ideas, as Roman concrete guides how to build in a manner that is more friendly to the environment and lasts longer. By discovering the secrets of this old material, today's society could create buildings that last not just for decades, but hundreds of thousands of years, just like the Romans used to do. I personally hope architects and engineers would find a way to blend this era into modern structures using cheaper modern-day materials. Imagine how much more pleasing our surroundings would be if our modern streets embraced a blend of classic and contemporary architecture, where the charm of history coexists with innovative design, creating a vibrant atmosphere that truly inspires. So, if you want to see great engineering achievements of the past and learn how they actually changed the world, make sure to hit the subscribe button. We look really closely into the stories that created our history, and there is a lot more to discover together. See you in the next video.